Okay, this is another video about factoring, but this time we're looking at a special case where the problems are called differences of squares. So there's not going to be trinomials. These are all going to be binomials. There are only two terms. If you'll notice, this says differences, so there's going to be subtraction. And it says squares, they're going to be perfect square numbers. So, for example, this is going to look something like a squared minus b squared. Some number squared minus some other number squared. So, before we can really start in on that, you need to make sure that you know what your perfect squares are. Okay, so let's think about that real quick. Perfect squares are numbers that, if I take the square root of them, it's a whole number. So, some whole number squared equals that. So 1 squared equals 1. 1 is a perfect square. 2 squared equals 4. That's a perfect square. 3 squared equals 9. 4 squared equals 16. 5 squared equals 25. And so on. So that's where I'm getting this list of perfect squares. So I'm going to go ahead and list some more. Okay, so that's all the way out to 15 squared. And so that's a really good place to kind of have memorized, and so that you can recognize that these numbers are perfect squares. So let's say that I have a problem, and my problem is x squared minus 4. So this looks like it might be one of those problems. So I've got x squared, so there's something squared, minus 4. 4 is the same thing as 2 squared. That's one of my perfect square numbers. And so the way this is going to factor, okay, if you look back up here at the top, a squared minus b squared, that's going to factor into a plus b times a minus b. Okay, so if I have x squared minus 4, that's going to factor into x minus the square root of 4, or x plus 2 times x minus 2. And you could write it the other way around also, x minus 2, x plus 2. It doesn't matter which parentheses goes first. All right, another example would be x squared minus 64. So, is 64 one of those perfect square numbers? Then it looks like this will factor as the difference of squares. What is the square root of 64? It's 8. So that's the number we're going to put in there in our factors, in our parentheses. So this will be x plus 8 times x minus 8. Another example would be x squared minus 25. So the questions we ask ourselves is this a perfect square? And what is the square root of that number? So this will be x plus 5 times x minus 5. So those are some basic examples of difference of squares. Sometimes they're a little bit more complicated than that, where we have numbers in both places. So I have 9x squared minus 4. So notice this time I have a number at the beginning and a number at the end, 9 and 4, but hopefully you'll recognize those are both perfect squares. So I'm going to need the square root of the 9 and the square root of the 4. So this factors into 3x plus 2 times 3x minus 2. Because 3 times 3 is 9, 2 times 2 is 4. Or if we had 100x squared minus 25. So those are both perfect square numbers, 100 and 25. So if I take the square root of each one, that will give me 10x plus 5, 10x minus 5. Okay, another example, 4x squared minus 81y squared. So this time I have variables in both places. So this would factor into 2x plus 9y times 2x minus 9y. And one last example, 32a squared minus 50b squared. So at first glance, this might look like this is one that wouldn't factor like the others. But if you'll notice, I could take out a common factor first. 32 and 50 could both be divided by 2. So I'm going to take out a 2. That's going to leave me with 16a squared minus 25b squared. Now that I've taken out that 2, I can see that this looks more like the other problems that I had, because 16 and 25 are both perfect squares. So this would be 2 times 4a plus 5b times 4a minus 5b. So it still factors, it's just you had to take out a common factor first before you could see your perfect square numbers and recognize that it really was a difference of squares.